Welcome to Space for Sleep, the channel where the wonders of the universe unfold in a calm and soothing voice. If you enjoy relaxing journeys through science, space, and the mysteries of existence, please consider subscribing and giving this video a like. It helps us grow and continue sharing peaceful, thought-provoking knowledge to accompany you day or night. Thank you for being here. And now, let's begin.
Dreaming of Tomorrow, Michio Kaku's universe. Imagine a future where our minds can connect across galaxies, where diseases are cured before symptoms appear, and where the boundaries of reality stretch far beyond what we ever thought possible. This is the world envisioned by Dr. Michio Kaku, a theoretical physicist, futurist, and one of the most compelling voices in modern science communication. In this audio journey, we will explore Kaku's most captivating ideas: time travel, parallel worlds, Type 1 civilizations, the mind of God, and the ultimate destiny of the cosmos. But we won't just focus on the far future. We'll uncover how today's scientific advancements are building the foundation for tomorrow's seemingly impossible breakthroughs. Michio Kaku has a unique gift, turning the complex mathematics of string theory into vivid cinematic visions of humanity's destiny. Through his lens, physics becomes a map of dreams, each theory a door to a new possibility, each discovery a key to the next great chapter of existence. This audiobook is not just an exploration of physics, it is an invitation to wonder, to think beyond our present limitations and ask the biggest questions of all. Where are we going? What will we become? And what awaits us at the edge of the known universe? Prepare to let go of everyday concerns. Let your mind drift across the dimensions, through the mysteries of time, and into the futures imagined by one of the brightest minds of our time. The universe is calling, and Michio Kaku is here to help us answer.
Chapter 1: The Mind of Michio Kaku, From Bronx Streets to Quantum Dreams. The story of Michio Kaku begins far from the ivory towers of academia. It starts in the rough neighborhoods of the Bronx, where a young boy, the son of Japanese-American parents held in internment camps during World War II, would gaze up at the night sky, not with fear or confusion, but with an aching curiosity. That boy would one day help define how we think about the very structure of space and time. Michio Kaku was born in 1947, just 2 years after the bombs dropped on Hiroshima and Nagasaki. The shadow of those events shaped much of his early thinking, as did the contrast between human destruction and the infinite serene dance of the cosmos above. While most kids played ball or watched cartoons, Michio was building atom smashers in his garage out of spare parts and scavenged materials, a feat that caught the attention of none other than Edward Teller, the father of the hydrogen bomb. But Kaku's ambitions were never about destruction. He wasn't chasing power, he was chasing understanding. His dream was to finish what Einstein had started, a theory of everything that could unify the forces of the universe: gravity, electromagnetism, the strong and weak nuclear forces, into a single, elegant equation. This would become the North Star of his life, the axis around which all his work would revolve. While studying at Harvard and later at Berkeley, Kaku dove into the world of string theory, a radical new idea suggesting that the fundamental particles we observe are not points, but vibrating strings, each with its own resonance. The mathematics was daunting, the implications mind-bending, but for Kaku, it was like discovering the Rosetta Stone of the cosmos. If correct, string theory could bridge the gap between the massive and the minuscule, between Einstein's relativity and the strange world of quantum mechanics. But Michio Kaku didn't want to stay hidden in academic circles. He knew that science needed a voice, someone who could translate abstract theories into something vivid and accessible. So he stepped into the public arena, writing books, giving lectures, appearing on TV, and speaking in a way that brought people along for the ride. His enthusiasm was contagious. Suddenly, black holes and higher dimensions weren't just abstract ideas. They were part of a living conversation about who we are and where we're headed. What set Kaku apart was not just his knowledge, but his imagination. He didn't stop at describing the world. He dreamed of what it could become. Could we build a space elevator? Could we one day digitize consciousness? Would we explore parallel universes or make contact with intelligent life in other dimensions? These questions weren't just science fiction. To Kaku, they were logical extensions of physics as we know it. He began categorizing civilizations by their technological maturity. A Type 1 civilization harnesses the energy of its planet. A Type 2 civilization captures the power of its star. A Type 3 civilization commands the energy of its entire galaxy. By this scale, humanity is barely at Type 0.7. But Kaku believes we are on the verge of becoming Type 1, a moment he calls the most dangerous in our species' history. Why? Because we now possess the tools for planetary destruction, but not yet the wisdom to wield them responsibly. It is, as he says, a race between enlightenment and extinction. This urgency fuels much of Kaku's work. His theories are not distant hypotheticals, they are roadmaps. He urges us to invest in green energy, planetary protection, and scientific literacy. He believes the future is not something that happens to us, it's something we build, thought by thought, choice by choice. And so, as we begin this journey through his universe, it's important to see Michio Kaku not just as a physicist, but as a bridge between the known and the unknown, between today's science and tomorrow's possibilities. He is a dreamer with equations in his hands, a builder of worlds we have yet to visit. In the chapters that follow, we'll step into those worlds. We'll look through Kaku's eyes at the very nature of reality, time, space, consciousness, and destiny. But before we explore the multiverse or travel through wormholes, we begin here, with a boy in the Bronx, staring up at the stars, daring to ask, what if? Because every theory begins with a question. And Michio Kaku never stopped asking.
Chapter 2. Parallel Realities. The Multiverse According to Kaku. What if everything you knew, your memories, your choices, your entire life existed not as a single thread through time, but as one of countless paths in an infinite forest of reality? What if every decision, every possibility created a new universe, branching out like a cosmic tree that never stops growing? For Michio Kaku, these are not merely questions for science fiction. They are serious propositions drawn from the frontiers of theoretical physics. At the heart of Kaku's exploration into the multiverse lies the provocative idea that our universe is not alone. Far from it. It may be just one of many, perhaps an infinite number, each governed by its own laws of physics, its own timeline, and its own version of reality. And if this is true, then everything you can imagine might already exist somewhere else. Another Earth, another you. To understand this radical idea, we must first revisit quantum mechanics, the mysterious, rule-bending theory that governs the behavior of the smallest known particles. In the quantum world, particles can exist in multiple states at once. A single electron can be in two places at the same time. A photon can behave as both a wave and a particle, depending on how we observe it. This concept, known as superposition, is as bewildering as it is essential. But it was Hugh Everett in the 1950s who proposed an even startling extension. What if these multiple states don't collapse into a single reality when we observe them, as the traditional interpretation says? What if instead each possible outcome splits off into a new universe? This is the foundation of the many worlds interpretation of quantum mechanics, and it's an idea Kaku has passionately embraced and expanded upon. In his vision of the multiverse, every event triggers a fork in reality. A coin toss doesn't just land heads or tails, it does both, in separate universes. The implication? Every version of history has unfolded somewhere. In one universe, ancient civilizations never fell. In another, humans never evolved. In yet another, you never pressed play on this audiobook. But how could we ever test this? How could we peer into another universe, or even know it exists? Kaku believes the answers may lie in the power of string theory. According to this elegant framework, all matter and energy are composed of tiny vibrating strings of energy, far smaller than atoms. Crucially, string theory only works in a universe with more than the 3 spatial dimensions we know. It requires 10 or even 11 dimensions, depending on the model. These extra dimensions could house other universes, worlds so close to us in a higher dimensional sense that they might be just a nanometer away, yet entirely unreachable under normal circumstances. This brings us to the notion of a multiverse hierarchy, a concept Kaku often explains using 4 levels. Level 1. Universes beyond our observable horizon. These are just extensions of our own universe, with different arrangements of matter but the same laws of physics. Level 2. Universes with different physical constants or laws. These arise from chaotic inflation, the theory that during the Big Bang, different regions of space inflated differently, creating bubble universes. Level 3. The quantum many worlds. Every possibility allowed by quantum mechanics is realized in a branching universe. Level 4. The most radical idea. Universes governed by entirely different mathematics. Here, reality itself could follow rules beyond our comprehension. Kaku doesn't claim all of this is proven. He's careful to acknowledge that the multiverse remains a bold and speculative idea. But what makes it so thrilling is that it offers explanations for some of the deepest mysteries in physics, such as why the constants of nature seem so perfectly tuned for life. If there are infinite universes, perhaps ours is simply one of the few where conditions allow for stars to form, planets to stabilize, and life to evolve. Beyond the science, there's something deeply poetic about this idea. It suggests that reality is not a closed book, but an infinite library. Somewhere, in another universe, there may be a world where your greatest regret never happened. A world where humanity has already reached the stars. A world where civilizations have unlocked the full potential of the cosmos. Kaku's multiverse is not a cold and distant idea. It's an invitation to imagine, to dream, to accept that the universe may be far more vast and mysterious than we ever dared to believe, and that perhaps, just perhaps, a role in it is still unfolding across a sea of possibilities. As we turn the page to the next chapter, we'll leave behind the infinite branches of reality and return to something that grounds all of Kaku's theories, the human future. Because while the multiverse may contain all versions of us, we live in this one, and what we choose to do with it matters more than ever.
Chapter 3. Visions of the Future. Kaku's predictions for the next 100 years. In the quiet corners of his mind, Michio Kaku often wanders not just through the stars, but through time itself. With a scientist's logic and a dreamer's heart, he has imagined what the next 100 years might bring to our civilization. This chapter unfolds like a whisper of tomorrow, an invitation to picture a world transformed by the steady, relentless current of scientific progress. Kaku has said many times that the future is not something we enter, it's something we create. And with that philosophy, he outlines a vision of the coming century that feels like science fiction, but is rooted in real trends, real technologies already blooming at the edge of our grasp. His predictions are not mere guesswork, they're carefully constructed extrapolations based on the accelerating pace of innovation, as seen through the lens of a theoretical physicist. He begins with the internet, which he believes is only in its infancy. In the future, the internet will be embedded into everyday objects. Your contact lenses will project augmented reality directly into your vision. Your wallpaper may display your emails. Your bathroom mirror will double as a medical scanner. We'll no longer carry devices, they'll be part of the fabric of our environment.
This is the Internet of Things taken to its fullest expression, seamless, invisible, and everywhere. Kaku also foresees a medical revolution. Diseases like cancer and Alzheimer's may be drastically reduced, not just by better drugs, but by nanotechnology, tiny machines that swim through your bloodstream, identifying and repairing damaged cells in real time. Medicine will shift from reactive to preventative. Genetic therapies will become routine, and life expectancy could easily stretch past 100 years for much of the population. But it doesn't end there. Artificial intelligence will become an ever-present companion. Kaku does not fear AI in the way that some do. He envisions it as an extension of ourselves, tools that enhance our lives rather than control them. Think of an AI assistant embedded in your home, your car, even your thoughts, offering advice, managing schedules, analyzing emotions, perhaps even composing music with you. The AI of the future, Kaku says, will be like electricity, invisible but indispensable. Space exploration, of course, holds a special place in his forecast. Kaku believes we will return to the moon permanently and go far beyond. A Mars colony is possible within a century, perhaps sooner. Private companies will play a huge role. He sees the moon as a gas station in space, its resources mined to fuel deeper journeys, and Mars, a proving ground for building a new world. Yet even more audacious is his idea of a planetary internet, using satellites and quantum encryption to connect every human on Earth in real time. He foresees a world where telepathy becomes feasible through brain-computer interfaces. You'll be able to transmit thoughts, not just words. Ideas, emotions, even dreams may one day be shared, like messages. Of course, not all is guaranteed. Kaku is honest about the risks. Climate change, pandemics, and technological misuse could slow or redirect these trajectories. But he insists that the arc of human progress, when paired with wisdom and cooperation, bends toward a brighter future. In education, Kaku imagines a transformation just as profound. Learning will be lifelong, personalized, and interactive. Classrooms will dissolve into the world itself, where students can walk with dinosaurs and holographic simulations, or explore the human brain from within using neural VR. Information won't be memorized, it will be experienced. And in energy, the world may finally break free from fossil fuels. Fusion power, solar satellites, and quantum batteries are all part of the picture. With unlimited clean energy, the foundations of civilization itself could be reimagined, ushering in an age of abundance. At the heart of Kaku's vision lies a deep optimism, one that is both rare and contagious. He does not believe the future is perfect. He knows there will be setbacks, dangers, and unexpected detours, but he is convinced that we are not helpless passengers in the great ride of time. We are its engineers. As the chapter closes, one can't help but feel that spark, the one Kaku always ignites, the quiet awe of imagining what humanity might become if we dare to dream boldly and act wisely. The stars may be far away, but the future, that begins now, with us.
Chapter 4: Parallel Worlds and the Quantum Dance. Michio Kaku often says that we are living in a quantum universe, not a classical one. At first glance, the world seems orderly. Planets orbit stars, apples fall to the ground, and light travels in straight lines. But when we peer deep into the atomic and subatomic realms, everything changes. Rules twist, particles blur, and reality itself becomes uncertain. This is the strange world of quantum mechanics. Kaku, like many theoretical physicists, has long been fascinated by the mind-bending implications of quantum theory. But unlike others, he dares to dream bigger. One of the ideas he explores with deep curiosity is the concept of parallel worlds, alternate universes that may exist alongside ours, born out of the very quantum fluctuations that underpin reality. To understand this, we must revisit a crucial principle in quantum physics: superposition. At the quantum level, particles do not have definite positions or velocities. Instead, they exist in multiple states simultaneously, until they are observed.
This bizarre behavior has been confirmed again and again by experiments, such as the famous double-slit experiment, where particles behave like waves until someone looks and then suddenly act like particles. This led physicist Hugh Everett III to propose in the 1950s the many-worlds interpretation of quantum mechanics. According to Everett, every time a quantum decision occurs, like whether a particle goes left or right, the universe splits. In one universe, the particle goes left. In another, it goes right. And both versions of reality continue to exist, branching endlessly. To many, this idea was absurd, but to Kaku, it was a beautiful consequence of the mathematics. If quantum mechanics is correct, and it has never been proven wrong, then the multiverse might be real. There could be an infinite number of universes, each slightly different, each containing a different version of ourselves. In one universe, you might be reading this audiobook while sipping tea. In another, you never found this channel. In yet another, you're an astronaut exploring Saturn's rings. The possibilities are not just vast, they are infinite. Kaku's approach is to blend these imaginative concepts with hard science. He shows that parallel universes are not just the realm of science fiction, but a plausible outcome of quantum theory and string theory. In fact, string theory, which attempts to unify all fundamental forces, naturally leads to the idea of a multiverse, a vast ocean of bubble universes, each with its own physical laws and constants. This raises philosophical questions as well. What does it mean to be you if there are infinite versions of yourself? Is consciousness also splitting across realities? Could we ever travel between these worlds, or are we forever confined to the one we inhabit? Kaku acknowledges that many of these questions remain unanswered, but he emphasizes that science is not just about what we know, it's about the bold pursuit of what we don't know. Exploring parallel worlds is not escapism, it's a natural extension of our quest to understand the cosmos. To detect other universes, we would need to look for cosmic fingerprints, strange patterns in the microwave background radiation, or signs of collisions between our universe and others. So far, the evidence is inconclusive, but the search is ongoing. Kaku's vision of the multiverse is not one of isolation, but of connection. He sees our universe as part of a larger cosmic symphony, where countless melodies play simultaneously, sometimes overlapping. The quantum dance is not chaos. It's an intricate choreography, and we are part of its rhythm. In your dreams tonight, imagine doors that open to other worlds, not metaphorically, but physically. Picture walking through one and finding a version of yourself who made different choices, lived different adventures, loved different people. These are not just fantasy, they are possibilities folded into the equations of physics. This is the essence of Kaku's wonder, to look at the smallest particle and see a vast cosmos reflected within it. To realize that reality is not a single thread, but a vast tapestry of many strands, all woven together in quantum harmony. And as we drift through this chapter of thought and wonder, the multiverse remains a soft murmur in the background of reality, a whisper from the edges of possibility.
Chapter 5. Teleportation, from science fiction to possible reality. The idea of teleportation has long captured human imagination, beaming from one place to another instantly, bypassing distance and time. It's a staple of science fiction, the Star Trek transporter, a magical device that deconstructs matter and rebuilds it elsewhere. But what does Michio Kaku say about teleportation? Is it mere fantasy, or is there a grain of scientific truth behind the dream? In this chapter, we explore the fascinating world of quantum teleportation, a process grounded not in moving matter through space, but in transmitting the information that defines a particle's state.
To understand this, we must first delve into the concept of quantum entanglement, which Kaku often describes as one of the strangest and most profound phenomena in physics. When two particles become entangled, their properties become linked in such a way that the state of one instantly determines the state of the other, no matter how far apart they are. Einstein famously called this spooky action at a distance, because it seems to defy the limit set by the speed of light. Scientists have experimentally demonstrated quantum teleportation with particles of light and atoms, transmitting the exact quantum state from one particle to another without moving the particles themselves. This breakthrough has major implications for quantum computing and secure communication. But what about teleporting humans? Kaku is clear. The teleportation of large objects, let alone people, remains a distant dream, limited by the immense complexity of encoding and reconstructing every particle in the human body. Our bodies contain roughly 7 octillion atoms, an almost unimaginably large amount of information. However, the theoretical groundwork opens doors. Kaku envisions a future where teleportation technology could revolutionize logistics, medicine, and communication. Imagine sending complex information instantly across vast distances, or using quantum teleportation for ultra-secure data transfer. The quantum world reveals that reality is not as fixed or limited as it seems. Particles dance between states, separated by space, but connected by information. Teleportation embodies this principle, information as the ultimate key to bridging distances. While the human transporter remains in the realm of dreams, teleportation at the quantum level is real and rapidly developing. This progress marks an important shift in how we think about space, information, and connection. Kaku often reminds us that many ideas once dismissed as science fiction are becoming science fact. Teleportation is one such example, a reminder that the boundary between imagination and reality is always moving. So as you drift into this chapter's reflections, consider teleportation not just as a fantasy, but as a glimpse into a future where the universe itself becomes a vast web of instant communication, connection, and possibility.
Chapter 6: Force Fields and Invisibility. Science Meets Imagination. The notion of force fields and invisibility has been a staple of science fiction for decades, conjuring images of shimmering shields around spaceships and cloaked figures moving unseen. But for Michio Kaku, these ideas are not just fantasy. They are concepts rooted in the fundamental laws of physics, slowly inching toward reality through innovative science. At the heart of this exploration lies the question, can we manipulate light and energy in ways that allow us to shield ourselves or render objects invisible? The answer, it turns out, is a complex dance of electromagnetic fields, material science, and cutting-edge engineering. One of the key breakthroughs making invisibility plausible is the development of metamaterials, engineered substances with properties not found in nature. Unlike ordinary materials, metamaterials can bend electromagnetic waves, including visible light, in unusual ways. This bending, known as negative refraction, allows these materials to guide light around an object, effectively making it disappear from view. Researchers have successfully created small-scale invisibility cloaks that work for microwaves and infrared light, and there is ongoing progress toward extending these effects to visible light. While practical, full-body invisibility remains a distant goal, the principle itself is firmly grounded in physics. Similarly, force fields, popularized by science fiction as protective energy barriers, can be interpreted through the lens of electromagnetic and plasma physics.
Kaku explains that while we may not yet have glowing, shimmering shields like those in Star Wars, it is possible to create plasma windows or electromagnetic fields that act as barriers, blocking particles or radiation. Such technologies could have applications in space travel, protecting astronauts from cosmic radiation, or in medicine, where focused fields could target cancer cells without damaging surrounding tissue. Beyond the practical, these concepts challenge our understanding of reality. They reveal the hidden potential within the electromagnetic spectrum, a vast range of energy that includes not only visible light, but radio waves, X-rays, and beyond. Kaku's fascination with these ideas stems from his broader vision of a universe where what once seemed magical or impossible becomes tangible through scientific discovery. He urges us to remember that today's cutting-edge research will be tomorrow's commonplace technology. The force fields and invisibility cloaks of fiction are stepping stones toward understanding the deeper workings of nature, the intricate dance of light and matter. As you listen, imagine a future where light bends at our command, where shields protect us from harm, and where invisibility is not a trick, but a tool. This chapter invites you to dream at the boundary between science and imagination, where the impossible edges closer to possible.
Chapter 7: The Future of the Mind, Exploring Consciousness and Beyond. One of the most profound mysteries that Michio Kaku often contemplates is the nature of the mind, the seat of consciousness, thought, and self-awareness. What is consciousness? How does the brain create the rich tapestry of our experience? And perhaps most intriguingly, can science one day unlock its deepest secrets to expand human potential? To Kaku, the mind is not merely a biological organ, but a quantum phenomenon, intertwined with the fabric of the universe. While neuroscience has made enormous strides mapping neurons and brain activity, the essence of consciousness remains elusive, hovering at the edge of scientific understanding. Recent advances in brain imaging, artificial intelligence, and quantum computing hint at a future where we might read thoughts, transfer memories, or even interface directly with machines. Kaku envisions a world where brain-computer interfaces become common, devices that could enhance cognition, restore lost senses, or allow communication without speech. In this vision, the boundaries between mind and machine blur. Could we upload consciousness into a computer? Could the self transcend the physical brain and exist as pure information? Kaku approaches these questions with both excitement and caution. While he is optimistic about technological possibilities, he also acknowledges the ethical, philosophical, and practical challenges involved. At the same time, he draws on concepts from quantum physics and string theory to suggest that consciousness might extend beyond classical materialism. Perhaps it is linked to higher dimensions or subtle quantum effects in the brain's microstructures. This chapter explores these ideas gently, weaving together cutting-edge science and philosophical wonder. We reflect on how our understanding of the mind could redefine what it means to be human. From neurotechnology to quantum mysteries, the future of consciousness is a frontier full of promise and uncertainty, a realm where science meets the very essence of existence. As you listen, allow yourself to imagine new possibilities, minds connected across space, thoughts flowing like light, and consciousness expanding beyond the limits we once imagined. Chapter 8: Artificial Intelligence and Consciousness, the New Frontier. The rise of artificial intelligence, AI, is one of the defining technological stories of our time. Yet beyond headlines and rapid developments, Michio Kaku invites us to look deeper, not just at machines getting smarter, but at what it truly means for consciousness, identity, and the future of human existence.
AI, in its simplest form, involves machines performing tasks that normally require human intelligence, from recognizing speech to playing chess, or even driving cars. But Kaku envisions a future far beyond this, a world where AI systems possess not only intelligence, but awareness, creativity, and perhaps even emotion. This idea raises profound questions. Can a machine ever be truly conscious? What is consciousness anyway? Is it a mere byproduct of biological neurons firing in a brain, or is it something more mysterious, possibly quantum in nature? Kaku points out that despite impressive advances, today's AI remains fundamentally different from human intelligence. Current systems learn patterns from data, but lack self-awareness or understanding. They do not possess desires, beliefs, or emotions. But as computational power grows and algorithms evolve, the gap may narrow. One possibility is that AI will develop forms of artificial consciousness, systems capable of experiencing the world subjectively. This challenges our understanding of life and mind, blurring lines between organic and synthetic beings. Kaku also explores the concept of hybrid intelligence, where humans and machines merge to enhance cognitive abilities. Brain-computer interfaces could allow direct communication with AI systems, expanding memory, processing speed, and sensory input. Imagine a future where your thoughts are seamlessly connected to vast networks of information, allowing instant access to knowledge and creative collaboration with intelligent machines. But with such power comes ethical dilemmas. Who controls AI? How do we ensure it aligns with human values? Could superintelligent machines surpass human control, leading to unintended consequences? Kaku stresses the importance of developing AI responsibly, with safeguards and a deep understanding of both technical and philosophical issues. He's hopeful that if managed wisely, AI can become humanity's greatest tool, extending our reach into new realms of knowledge, creativity, and discovery. Beyond technology, Kaku reflects on the broader implications of artificial consciousness. What does it mean for identity and the soul? If machines can think and feel, how do we define what it means to be alive? This chapter invites listeners to ponder these mysteries gently, exploring the evolving relationship between humans and their creations. As AI becomes more integrated into daily life, we face choices that will shape the future of our species. In quiet moments, consider this: the mind you call your own might one day be complemented or even merged with an intelligence not born of flesh, but of circuits and code. The journey is just beginning.
Chapter 9. The Space Elevator, Reaching for the Stars. One of Michio Kaku's most ambitious and inspiring visions for humanity's future is the construction of a space elevator, a monumental engineering project that could revolutionize space travel and open the cosmos to everyone. Imagine a cable stretching from Earth's surface far beyond geostationary orbit, anchored to a counterweight in space, with robotic climbers ascending and descending this tether. This structure would allow us to transport cargo, satellites, and even people into space more cheaply, efficiently, and safely than current rocket technology. The idea of a space elevator might sound like science fiction, but it has deep roots in physics and engineering. It was first proposed by Russian scientist Konstantin Tsiolkovsky in 1895, inspired by the Eiffel Tower. Since then, advances in material science and nanotechnology have brought this dream closer to reality. One major challenge has been finding a material strong enough to withstand the immense tension on the cable. Carbon nanotubes and graphene, materials just a few atoms thick yet incredibly strong, offer hope that we could build a tether capable of supporting the elevator's weight. Kaku explains that a space elevator could dramatically reduce the cost of sending payloads to orbit, from thousands of dollars per kilogram by rocket to mere hundreds or less. This would enable more frequent launches, permanent space stations, and eventually colonies on the Moon or Mars. Beyond logistics, the space elevator could serve as a platform for scientific research and energy generation.
Solar power satellites positioned at high altitudes could beam energy to Earth, providing clean, abundant electricity. But the space elevator is more than an engineering project. It is a symbol of humanity's potential, a bridge from our terrestrial home to the vastness beyond. Kaku believes it represents the first step toward becoming a Type 1 civilization, harnessing planetary resources and expanding into the solar system. As you listen, picture this massive cable extending into the sky, shimmering under the sunlight, with climbers slowly ascending like ants. Imagine the possibilities unlocked by such technology: space tourism, asteroid mining, and perhaps one day, interstellar travel. While many obstacles remain, economic, technical, and political, the space elevator embodies the spirit of exploration and innovation that defines our species. In the quiet of your mind, dream of this ladder to the stars, a pathway to new horizons waiting just beyond the clouds. Chapter 10. The Search for Extraterrestrial Intelligence. Are we alone? One of the most profound questions humanity has ever asked is whether we are alone in the vast cosmos. Michio Kaku often speaks about this topic with a mixture of scientific rigor and hopeful wonder, inviting us to consider the possibilities that lie beyond our tiny blue planet. The search for extraterrestrial intelligence, or SETI, has been ongoing for decades, using powerful telescopes and sophisticated algorithms to listen for signals from other civilizations. The idea is simple yet profound. Somewhere, out there, an intelligent species might be broadcasting messages or inadvertently emitting radio waves that we can detect. Kaku emphasizes that the universe is incredibly old, about 13.8 billion years, and unimaginably vast, containing hundreds of billions of galaxies, each with billions of stars and even more planets. Given these staggering numbers, the probability that life has arisen elsewhere seems almost inevitable. However, the Fermi paradox presents a puzzling contradiction. If extraterrestrial civilizations are common, why haven't we seen clear evidence of them? Where is everybody? Several explanations have been proposed, ranging from the rarity of intelligent life to the possibility that advanced civilizations self-destruct before reaching the capability for interstellar communication. Kaku is optimistic but cautious, suggesting that we may be at a critical point in cosmic history, either just beginning to explore or still awaiting contact. He explores concepts like the Drake equation, a formula that estimates the number of communicative civilizations in our galaxy. While the variables are uncertain, the equation frames our quest scientifically and provides a hopeful framework. Beyond radio signals, Kaku also discusses newer approaches, such as searching for technosignatures, indicators of advanced technology like megastructures, think Dyson spheres, or atmospheric markers of industrial activity. The idea of discovering extraterrestrial life carries immense philosophical and practical implications. Would contact unite humanity or cause upheaval? How would it reshape our understanding of ourselves and our place in the cosmos? Kaku encourages us to keep listening, exploring, and dreaming. The silence of space may be temporary, a prelude to a grander discovery. As you drift into this chapter's reflections, imagine the quiet hum of distant stars, the possibility of other minds reaching out across the void, and the shared destiny of intelligent life in the universe.
Chapter 11. The Quantum Universe. Understanding Reality's Deepest Layers. Michio Kaku often describes the universe as a vast quantum realm, where classical laws of physics give way to strange and beautiful phenomena that challenge our intuition. In this chapter, we explore the foundations of the quantum universe, the mysterious world beneath the atoms and particles that compose everything around us. At the core of quantum physics lies the idea that particles are not just tiny solid points, but waves of probability existing in multiple states until observed. This leads to paradoxes such as Schrödinger's famous cat, simultaneously alive and dead, until a measurement collapses the wave function into a definite state. Kaku delves into the notion that reality at the smallest scales is fundamentally uncertain and interconnected. Particles can become entangled, sharing information instantly across vast distances, a phenomenon Einstein called spooky action at a distance. Moreover, quantum mechanics challenges the classical idea of locality and causality, introducing concepts like quantum tunneling, where particles pass through barriers they shouldn't be able to cross. Kaku connects these ideas to the broader quest of theoretical physics, unifying quantum mechanics with gravity into a single elegant theory. String theory is one of the leading candidates, proposing that fundamental particles are tiny vibrating strings whose modes create the variety of particles we observe. The quantum universe invites us to reconsider what is real, blurring lines between matter and energy, wave and particle, observer and observed. Kaku highlights how these discoveries have profound implications not only for physics, but also for philosophy and our understanding of existence. As you listen, allow your mind to drift into this quantum sea, where uncertainty is a fundamental feature and the fabric of reality is alive with vibrations, waves, and connections beyond space and time. Chapter 12: Black Holes and the Edge of Time. Black holes have long captivated human imagination, mysterious regions where gravity is so intense that nothing, not even light, can escape. Michio Kaku often discusses black holes as cosmic laboratories, offering clues to the deepest laws of physics and the nature of time itself. A black hole forms when a massive star exhausts its nuclear fuel and collapses under its own gravity, compressing matter into an infinitely dense point known as a singularity. Surrounding this is the event horizon, the point of no return. Crossing it means being trapped forever. Kaku explains how black holes challenge our understanding of space and time. Near a black hole, time slows dramatically, a consequence of Einstein's theory of general relativity. For an outside observer, someone falling into a black hole appears to freeze in time at the event horizon. Black holes also raise profound questions about information. According to classical physics, anything crossing the event horizon is lost forever. But quantum mechanics suggests information cannot be destroyed, leading to the famous black hole information paradox. Recent theories propose that black holes might be gateways to other regions of the universe or even other universes. Some suggest that inside a black hole, space-time might connect to a white hole or wormhole, hypothetical passages through the fabric of reality. Kaku often describes black holes as the ultimate testing grounds for uniting quantum mechanics and gravity. Understanding them could reveal a theory of quantum gravity, unlocking the secrets of the universe's origin and fate. As you listen, imagine the cosmic dance around a black hole, the swirling accretion disk of superheated matter, jets of plasma shooting into space, and the silent pull of gravity warping time and space. These enigmatic giants remind us how much remains unknown, and how curiosity drives us to explore the edge of reality itself.
Chapter 13: Quantum Computing, the Dawn of a New Age. In the ever-accelerating journey of technology, few developments hold as much promise as quantum computing. Michio Kaku often highlights this field as a revolutionary leap poised to reshape industries, solve problems once deemed impossible, and transform our understanding of computation itself. Traditional computers operate on bits, units of information that are either 0 or 1. Quantum computers, by contrast, use quantum bits or qubits, which can exist in a state of 0, 1, or both simultaneously, thanks to the phenomenon known as superposition. This allows quantum computers to process an enormous number of possibilities all at once. But quantum computing goes beyond mere speed. The true power lies in its ability to tackle problems with vast complexity, such as factoring enormous numbers, optimizing logistical networks, or simulating molecular interactions at the quantum level.
These tasks are often intractable for classical computers, but quantum algorithms can approach them efficiently. Michio Kaku explains that quantum entanglement further enhances this power. Entangled qubits are linked so that the state of one instantly affects the other regardless of the distance between them. This connectivity enables quantum computers to perform parallel computations in ways classical machines cannot match. The implications for fields like medicine, cryptography, and artificial intelligence are profound. Quantum simulations could unlock new drug designs by modeling complex molecules with precision. Cryptography could evolve, both threatening current security methods and inspiring new ones based on quantum principles. AI systems may benefit from enhanced processing, learning, and adaptation. However, quantum computing also faces significant challenges. Qubits are incredibly sensitive to external disturbances, making it difficult to maintain stable computations, a problem known as quantum decoherence. Building scalable, error-corrected quantum computers requires groundbreaking advances in engineering and materials science. Kaku is optimistic that ongoing research and investment will overcome these hurdles. He envisions a future where quantum computers operate alongside classical ones, augmenting human capabilities and unlocking mysteries of the universe. Moreover, quantum computing could shed light on the very nature of reality. By simulating quantum systems, we might deepen our understanding of the quantum fabric that underpins existence itself. As you listen to this chapter, imagine a world transformed by these strange, powerful machines, where problems once thought unsolvable are cracked open, and the boundary between human imagination and technological capability fades. Quantum computing is not just a new tool, it is the dawn of a new age, one where the quantum dance of particles becomes a symphony of knowledge, innovation, and discovery. Chapter 14. The Multiverse, Beyond Our Universe. One of the most fascinating and mind-expanding ideas in modern physics is the concept of the multiverse, the existence of multiple, perhaps infinite universes beyond our own. Michio Kaku often explores this topic with a blend of scientific rigor and poetic imagination, inviting us to consider realities far beyond the familiar stars. The multiverse concept arises naturally from several areas of theoretical physics, including inflationary cosmology, string theory, and quantum mechanics. It challenges the idea that the universe we observe is the only one, proposing instead a vast cosmic landscape filled with diverse universes, each with its own laws, constants, and histories. In inflationary theory, our universe's rapid expansion after the Big Bang may have produced countless bubble universes, each inflating independently and perhaps with different physical properties. String theory's complex mathematical framework also predicts a landscape of possible vacuum states, each corresponding to a different universe. Kaku suggests that this multiverse could explain some of the deepest puzzles in physics, such as why our universe's constants appear finely tuned for life. Perhaps countless universes exist, and we live in one where conditions are just right for stars, planets, and life to emerge. The idea raises profound philosophical questions. Are these other universes accessible? Could there be versions of ourselves living alternate lives? What does this mean for fate, free will, and the uniqueness of existence? While direct evidence remains elusive, physicists look for clues, subtle imprints in the cosmic microwave background radiation, or unusual gravitational effects that might hint at collisions between universes. Kaku emphasizes that exploring the multiverse is not escapism, but a natural extension of humanity's quest to understand reality in its full grandeur. As you listen, allow your mind to wander beyond the familiar, imagining an endless sea of universes, a cosmic symphony of possibilities that expands the horizons of wonder and knowledge.
Chapter 15. The Fate of the Universe, From Heat Death to New Beginnings.
The universe, vast and majestic, is not eternal in its current state. Michio Kaku often reflects on its ultimate fate, a destiny shaped by physics, cosmology, and the mysterious forces governing cosmic expansion. One leading scenario is the heat death, where the universe continues to expand, stars burn out, and energy becomes evenly spread. In this cold, dark future, no new stars form, and entropy reaches its maximum, leaving a silent and lifeless cosmos. Alternatively, the universe might experience a big rip, where expansion accelerates to such extremes that galaxies, stars, planets, and eventually atoms themselves are torn apart. This dramatic end reflects the enigmatic nature of dark energy, the force driving accelerated expansion. Another possibility is the Big Crunch, a reversal where gravity overcomes expansion, causing the universe to collapse back to a hot, dense state, potentially leading to a new Big Bang and a cyclical model of cosmic rebirth. Michio Kaku also entertains more speculative ideas, like the Big Bounce, where the universe oscillates through cycles of expansion and contraction, or even the emergence of new universes through quantum fluctuations. These scenarios not only predict physical outcomes, but touch on philosophical questions about time, existence, and the meaning of the cosmos. Kaku emphasizes that while the distant future is uncertain, understanding these possibilities enriches our grasp of the universe's nature and inspires awe at the grand cosmic story unfolding. As you listen, envision the slow fading of stars, the vast silence stretching across space, and the hopeful spark that perhaps from endings arise new beginnings. Chapter 16. Wormholes, Cosmic Gateways Through Space and Time. Among the most tantalizing ideas in physics are wormholes, hypothetical tunnels through space-time that could connect distant parts of the universe, or even different universes altogether. Michio Kaku often explores wormholes as a bridge between imagination and scientific possibility, teasing the boundaries of what might be achievable. Wormholes emerge naturally in Einstein's theory of general relativity, as solutions to the equations describing the curvature of spacetime. Picture spacetime as a flexible fabric. A wormhole is like a shortcut folding this fabric, creating a tunnel between two distant points. In theory, traversable wormholes could allow instant travel across vast cosmic distances, bypassing the speed of light limit that constrains conventional space travel. This concept has captured the imaginations of science fiction writers and physicists alike. However, building or stabilizing a wormhole would require exotic forms of matter with negative energy density, something not yet observed but theoretically permissible. Michio Kaku discusses how advances in quantum field theory and string theory might provide insights into such exotic matter. Wormholes also raise profound questions about causality and time travel. Could a wormhole allow journeys into the past, potentially leading to paradoxes? Kaku emphasizes the need for rigorous physics to understand these possibilities and prevent contradictions. While practical wormhole travel remains speculative, ongoing research into the fabric of spacetime continues to unveil surprising phenomena, hinting that nature's design might be more flexible than once thought. As you listen, imagine stepping through a shimmering tunnel of light, emerging in a distant galaxy or a parallel universe. Wormholes invite us to dream beyond the confines of space and time, exploring new frontiers of cosmic connectivity. These gateways remind us that the universe is full of mysteries waiting to be uncovered, and that the boundaries of science are ever expanding.
Chapter 17. The Cosmic Symphony, Music of the Spheres. Throughout history, humans have been fascinated by the idea that the cosmos itself is a kind of music, an orderly harmony underlying the apparent chaos of the universe. Michio Kaku often returns to this ancient concept, weaving it into modern physics and cosmology as a poetic metaphor and scientific reality. The phrase, music of the spheres, dates back to the ancient Greeks, who imagined the movements of celestial bodies producing a cosmic harmony. Today, string theory, one of Kaku's favorite frameworks, gives this idea a new twist. Fundamental particles are not point-like dots, but tiny vibrating strings, each vibration producing different particles, much like notes from a violin string. In this view, the universe is a vast symphony of vibrating strings, each contributing to the melody of existence. The fundamental forces and particles arise from these vibrations, creating the rich tapestry of matter and energy. Kaku also discusses how gravitational waves, ripples in space-time caused by massive cosmic events like black hole collisions, can be thought of as a cosmic music we are only beginning to hear. Detectors like LIGO have opened a new way of listening to the universe, revealing sounds previously silent to human senses. Moreover, the cosmic microwave background radiation, the faint afterglow of the Big Bang, can be analyzed like a piece of music, containing subtle patterns and fluctuations that tell the story of the universe's birth and evolution. This chapter invites listeners to imagine the universe not just as a physical place, but as a grand concert, where everything vibrates, pulses, and resonates. It's a reminder that science and art often intertwine, revealing beauty in the fundamental laws of nature. As you listen, picture the vast cosmos as an orchestra, each star and planet a musical instrument playing its part in a never-ending cosmic symphony. Chapter 18: Dark Matter and Dark Energy, the Invisible Universe. One of the most intriguing mysteries of modern cosmology is the discovery that the vast majority of the universe is made up of substances we cannot see, dark matter and dark energy. Michio Kaku often discusses these elusive components as keys to understanding the universe's fate and structure. Dark matter, first hypothesized due to its gravitational effects on visible galaxies, acts like an invisible scaffold holding cosmic structures together. Without it, galaxies would fly apart, unable to maintain their shape. Yet despite its profound influence, dark matter does not emit, absorb, or reflect light, making it invisible to traditional telescopes. Dark energy, even more mysterious, is the force driving the accelerated expansion of the universe. Discovered in the late 1990s through observations of distant supernovae, dark energy acts as a repulsive force, pushing galaxies away from each other at ever-increasing speeds. Kaku explores how these unseen forces dominate the cosmic budget. About 27% is dark matter, around 68% dark energy, and only a mere 5% ordinary matter, everything we know and see. Scientists worldwide are engaged in ambitious experiments to detect and understand dark matter particles, while cosmologists work to grasp the nature of dark energy, possibly linked to the energy of the vacuum or new physics beyond current models. Understanding these components could unlock profound insights into the universe's origin, evolution, and ultimate destiny. Kaku emphasizes that these invisible forces challenge our perception of reality, hinting at deeper layers yet to be discovered. As you listen, imagine a universe filled mostly with the unknown, vast, silent, and invisible, realms shaping everything we experience.
Chapter 19: Time Travel, Dreams and Paradoxes. Time travel has long captured the imagination of scientists and storytellers alike. Michio Kaku often discusses the concept not as mere fantasy, but as a topic grounded in real physics, wrapped in mystery and paradox. Einstein's theory of relativity opened the door to the possibility that time is not absolute. Time can dilate, speed up, or slow down depending on speed and gravity. This has been experimentally confirmed with precise clocks on airplanes and satellites. Kaku explores the idea that traveling forward in time is theoretically possible, for example, by moving close to the speed of light, or near massive gravitational fields, you could age more slowly relative to others. But traveling backward introduces paradoxes, like the famous grandfather paradox, where altering the past could prevent one's own existence. Physicists have proposed solutions to these paradoxes, such as the idea of parallel universes or timelines branching off to avoid contradictions. Wormholes, if stable, could offer shortcuts through time, though creating and controlling them remains beyond our reach. Kaku emphasizes the importance of scientific rigor when approaching time travel. While current technology makes it impractical, understanding these concepts pushes physics forward and deepens our grasp of space-time. As you listen, let your mind wander through the fabric of time, contemplating the possibilities and mysteries that lie beyond our everyday experience. Chapter 20: The Human Future Among the Stars. As we reach the culmination of this journey through Michio Kaku's vision of the cosmos, it is fitting to reflect on humanity's place and destiny among the stars. The universe, vast and ancient, invites us not just to observe, but to participate, to become explorers, innovators, and caretakers of a cosmic future. Michio often speaks about humanity's potential to evolve beyond our planetary cradle. Advances in space technology, bioengineering, and artificial intelligence hint at a future where humans may live on other worlds, adapt to new environments, and extend life far beyond Earth. One of Michio Kaku's core ideas is the progression through Kardashev's scale. From a Type 1 civilization, mastering planetary energy, to Type 2, harnessing the power of a star, and eventually Type 3, commanding the energy of entire galaxies. Humanity is still at the dawn of this journey, but the path forward is rich with promise. The challenges are immense: cosmic radiation, vast distances, and the limits of biology. Yet so too are the opportunities. Colonizing Mars, mining asteroids, and developing self-sustaining space habitats could become realities within this century. Moreover, Michio emphasizes the importance of maintaining the delicate balance between technological advancement and ethical stewardship. Our cosmic future depends not only on innovation, but on wisdom, cooperation, and a sense of shared destiny. In this chapter, we imagine the quiet nights on distant planets, the first footprints on alien soil, and the songs of new civilizations yet to arise. The stars call to us not as distant lights, but as beacons of possibility and hope. As you listen, let your thoughts drift among the galaxies, embracing the wonder of the universe and the extraordinary potential within each of us to shape its future.